Every airplane begins long before the factory. Deep beneath the Earth's bauxite ore is extracted, the essential mineral that will eventually become the lightweight aluminum structure of modern aircraft. Powerful excavators remove thousands of tons of ore every day, supplying the raw aluminum needed for one of humanity's most advanced engineering achievements. Although it appears like ordinary stone, this mineral contains the aluminum that will soon be transformed into the backbone of an aircraft. After extraction, the ore begins its first journey, moving from the mine toward specialized refineries where its transformation truly begins. The refining process begins by crushing the ore into smaller particles, preparing it for the complex chemical stages ahead. Inside these enormous processing vessels, impurities are separated from valuable aluminum compounds through carefully controlled chemical reactions. At temperatures exceeding hundreds of degrees, purified aluminum becomes liquid, allowing it to be cast into strong industrial forms. Once cast and cooled, the aluminum billets become the starting point for manufacturing countless aircraft components. Every billet is carefully tracked before entering the aircraft factory, ensuring complete traceability throughout the production process. After refinement, the aluminum reaches one of the world's most advanced manufacturing facilities, where raw metal begins its transformation into a modern airplane. Every billet is carefully handled to prevent damage before entering the precision manufacturing process. Advanced laser systems verify dimensions with extraordinary accuracy before machining begins. Internal inspections ensure every piece of aluminum meets strict aerospace safety standards. Each billet is digitally identified, allowing every future aircraft component to be fully traceable. Before machining, every surface is thoroughly cleaned to eliminate contaminants that could affect manufacturing precision. Cleaned components are carefully dried to create the perfect surface for precision. Machining, powerful computer-controlled machines remove material with incredible precision, producing complex structural components. Every movement is measured in fractions of a millimeter, ensuring perfect dimensional accuracy. Automation allows each finished component to move efficiently toward the next stage without unnecessary handling. After precision machining, the components continue to the forming department, where their final aerodynamic shapes begin to emerge. Enormous hydraulic presses gradually shape thick aluminum panels into the curved forms that define an aircraft's aerodynamic body. Stretch. Forming distributes force evenly across the metal, creating smooth curves without weakening the material. Each newly formed section is verified immediately to ensure it matches its digital design. Precision rollers create the gentle aerodynamic curves essential for efficient lift during flight. Surface finishing removes tiny imperfections while preparing every panel for protective treatment. A specialized protective primer shields the aluminum from corrosion throughout decades of service. Controlled heat permanently bonds the protective coating to the aluminum surface. Advanced laser systems complete every edge with exceptional consistency and precision. Thousands of precision-drilled holes ensure every structural connection meets strict aerospace engineering requirements. With every major component complete, the journey now enters the heart of aircraft manufacturing, the final assembly line. Assembly begins by precisely positioning the aircraft's massive fuselage sections before they are permanently joined together. Advanced alignment systems ensure every section connects with exceptional geometric accuracy. Thousands of high-strength rivets permanently lock the aircraft structure into a single unified frame. Each wing is carefully maneuvered into position using synchronized lifting systems capable of extraordinary precision. The wing-to-body connection is one of the strongest structural joints found anywhere on the aircraft. Before the aircraft can fly, its wings must house complex hydraulic, electrical, and fuel distribution systems. Specialized lifting systems position the landing gear, allowing the aircraft to safely support hundreds of tons. The aircraft's engines are installed with exceptional precision, becoming the powerful heart of the finished airplane. Thousands of electronic connections integrate the cockpit with every major system throughout the aircraft. With the primary structure complete, the aircraft is ready for detailed finishing, system integration, and the final stages of craftsmanship. The interior assembly begins with insulation systems that improve passenger comfort while reducing cabin noise throughout every flight. Complex electric networks connect lighting, communication, navigation, and passenger systems throughout the aircraft. Every cabin component is carefully installed to balance safety, durability, And passenger convenience. Passenger seating is mounted with precise torque specifications to ensure maximum safety during every flight. The aircraft's sophisticated avionics are powered for the first time, initiating thousands of automatic diagnostic checks. Experienced engineers verify every critical connection before the aircraft advances to system testing. A controlled painting environment ensures flawless coverage while protecting the aircraft from harsh environmental conditions. Multiple layers of specialized aerospace coatings create both a striking appearance and long-term surface protection. The final polishing process enhances the protective finish while producing the aircraft's signature high-gloss appearance. With assembly and finishing complete, the aircraft now enters the most demanding stage of production: comprehensive inspection and certification. High-precision laser scanners verify every exterior dimension to ensure the finished aircraft matches its digital design. Non-destructive testing allows engineers to examine critical structures without affecting the aircraft itself. Every hydraulic system is tested repeatedly to verify reliable operation under demanding flight conditions. The cabin is carefully pressurized to confirm its ability to withstand the demanding conditions of high-altitude flight. The first engine start confirms the successful integration of mechanical, electrical, and fuel systems. Thousands of onboard systems communicate simultaneously, confirming the aircraft is ready for operational testing. Every inspection result is independently verified before the aircraft proceeds toward flight readiness. The first ground movement confirms the successful integration of steering, braking, and propulsion systems. A final visual inspection confirms every system and surface meets the highest aerospace quality standards. After passing every inspection, the aircraft begins its final journey from the factory floor to the runway. The finished aircraft is carefully positioned for its final preparations before entering operational service. One final diagnostic confirms every onboard system is operating exactly as designed. The aircraft receives its first full fuel load, preparing it for the next stage of operational testing. A final walk-around inspection confirms every external component is ready for flight. With every inspection complete, the aircraft begins its journey toward the runway. The engines gradually reach takeoff power, generating the immense thrust required for flight. Powerful engines propel the aircraft forward as years of engineering culminate in a single defining moment. The aircraft lifts effortlessly into the air, marking the successful completion of its manufacturing journey, from raw aluminum to a flying masterpiece. Every component now performs together as a single engineering achievement. Every flight begins with countless hours of precision, innovation, and craftsmanship, transforming raw materials into one of humanity's greatest engineering achievements. After months of engineering and assembly, the aircraft is finally ready to begin the purpose for which it was created. A successful landing marks the final confirmation of countless manufacturing processes working together perfectly. Every precisely manufactured component now operates together exactly as its engineers intended. The manufacturing journey ends where every passenger's journey begins. Even after the engines fall silent, every detail reflects the precision invested during manufacturing. Every interior detail is designed to combine comfort, safety, and efficiency for millions of travelers. Behind every safe flight is an ongoing commitment to quality that continues long after manufacturing. Each aircraft represents years of engineering, advanced manufacturing, and the dedication of thousands of skilled professionals. Thousands of precisely manufactured parts unite to create a machine capable of safely connecting people across the world. From the first piece of aluminum to the open skies, every stage reflects the remarkable precision behind modern aircraft manufacturing. Every successful flight is the result of extraordinary engineering, advanced manufacturing, and thousands of precisely coordinated production steps. From raw minerals hidden beneath the earth to a machine capable of crossing continents, every stage demands absolute precision. Behind every visible detail lies countless hours of precision machining, inspection, assembly, and craftsmanship. Modern aviation connects nations every day, supported by the remarkable manufacturing processes that make safe flight possible. From the first cut of aluminum to this moment above the clouds, every stage reflects humanity's pursuit of engineering excellence. Every airplane tells a story of innovation, precision, and human ingenuity, transforming raw metal into a machine that carries millions safely across the skies.